to answer the questions. Let me see here. Not quite tall enough there. There we go. Okay. There's the graph. And now I'm going to start putting some questions up here, and you can see if you can answer them. All right?
Does the graph start at just number 1 and then go to 2, 3, 4? Because the numbers are a little bit blurry for us.
Yeah, let me do something here. See if this helps you at all. Did that do anything? Yes?
Yes.
Okay. All right. So first thing I want to know, what is f of negative 5? Next thing, I want to know what is f of negative 6. Next, what is f of 4? Next thing, where is f of x greater than 0? So that means where is it positive? Where is f of x negative? Where is f of x 0? Find the domain of f, find the range of f. And by the way, this is a function, isn't it? Is that a function? Does it pass the vertical line test? Are there any places where you draw and hit the graph more than once?
Where y equals 0?
Okay, so see how I have an open circle here? And here it's solid? I did that on purpose. It means that at this point it's not defined. So you only are going to hit it in one spot. So that's the important difference between the open circle and the solid dot. Okay, why don't you work on that, talk to each other, and I'll come right back and check on you. I've probably had 30 texts in like the last 5 minutes. I'm going to make sure everything's okay. If you have a question, let me know, because I'm going to call on you kind of randomly here. No questions? Desiree, you okay at home?
Yes.
Okay. Sorry. Lorena, are you okay?
Yes.
Okay. All right. You need more time? I can give you a little more time. All right.
Sure, how would I write the domain if there's space?
Yeah. How do you do that? I'm going to be curious to see. For domain, did you try something, or are you just thinking about how to do it? Just if there's breaks, then how did you deal with breaks before? Whenever we had like two different sets, right? Like two different intervals. So just do that with a little u, and you should be okay. Nobody has a question?
On domain for the open circle would be a parentheses, and then with the black dot, it would be a bracket, right?
That is correct. That is correct. Can you hear me? Yes?
Yes.
Okay, yes. Anytime you have an open circle, that means you can't include that point. So yes, that will correspond to parentheses or brackets.
And then we use the U to combine them.
You use a union to combine them. So Juan, you get that? Think you got that? Okay. Let's just go like another minute. Okay, I think that's probably good. So how about our Zoom students? How about that? Lorena, you want to go first?
For A, I got -2.
Oh, wait, hold on. I'm trying to find you. Where are you? Lorena and Desiree. Oh, geez. Okay, so Lorena, for A, what did you get?
-2.
-2. What do y'all think? Everyone agree? So this is -2. Okay, go out to -5. Here we go. Okay, Lorena, keep going.
-1.
Okay, so you went out to -6. In here, Lorena, it's an open circle, right?
Yeah.
That means that there is no point there, right? That means there is no output for the function. This is the first time we've had this, right? So it would be undefined. I understand what you were thinking. You were thinking -1 because of this, right, Lorena?
Yes.
But because it's open, it's undefined. Now, had that been a solid dot, then we would say -1. So for here, undefined. Lorena, does that make sense?
Yes.
Okay. All right, how about f of 4? Lorena?
1.
1? Okay, that's here. I didn't put a dot, but it's kind of, you can kind of tell. Okay, 1, good. All right, let's move on. Desiree, you want to take over?
Yeah, I wasn't 100% sure how to do D and E.
Okay, well, let's go through it together. So where's the function positive? So visually that means where is it above the x-axis, right? Where is it above the x-axis? So where does it start? Where does it start being above the x-axis to you?
At the 0, -1, or 0, 1.
0, 1. Here?
No, it would be 0 and then up 1.
Oh, yeah, I agree. It is above the x-axis here. Yes, it is. But also here, right? Like every point here, it's above the x-axis. All the way until you get to where?
0, -2.
This one right here, right? -2.
Yeah.
So between -2 all the way to 0, right, everyone? Between -2 to 0, your graph is above the x-axis. That makes sense, Desiree?
Yes.
Okay, so the way I'm going to write that is -2 to 0. Now, it's important to understand why I put a parenthesis on -2 and a bracket on 0. At -2, what's the value of the function? Everyone, what's the value of the function at -2? 0. And we want to know where it was positive, greater than 0. So we do not include -2. But as soon as you get to the right of -2, it starts being positive until you get to 0. And when you're at 0, it is positive, right? So I want to include 0. Desiree, does that make sense?
Yes.
Okay, now we're not done though, right? Because there's another place. Go ahead.
I thought you said that 0 was positive.
0 was not positive?
Yes. In the last one of the last functions, you were saying that 0 wasn't really considered a positive number.
It's the output. So when you plug 0 in, right? When you plug in 0, the output is positive,
Okay.
right? So what we mean here is if you plug in any of these values for x, right? Any of these x values, your function's going to spit out a positive number.
Yes.
You can't include -2, right? Because at -2, it spits out 0, which is not positive. That's why I'm not including -2. But at 0, you plug in, you get 1, which is positive.
Okay.
So I include that.
Okay.
So we're not done. We have to continue. And that would be all these points here, right? Everything here are all above the x-axis. So it starts out at 2, and it goes until you get to 5. Everything between 2 and 5. So I go 2, 5. Now, do I include the 2 endpoints or not? At the 2, you don't, right? Because at 2, you're 0. So I don't want to include that. How about at 5? It's an open circle, so you can't say at 5 it's positive, because what is the value of the function at 5? It's undefined. Okay, so you can't include that. Then it put a union between them. Desiree, did that help at all?
Yes, thank you.
Okay. Anybody else have questions on that? This is the answer to part D.
I did have a question on
Yes.
that. So on the online homework for the graphs, I already, because I did 3.2, but on the graphs, it only tells you to use the points that are given. So like if there's a dot on one, then you use that. But if there's no dot, then we don't include them. So I was confused on that.
I'll have to look at it when I do it. Yeah, let me look at it when I do it. As long as you can understand what I'm doing here, you'll be good. Because this is the way it'll be on a test.
Okay.
Remember, the whole idea of this class was for you to be doing your homework out of the book, but not online. Like, it was never designed that you're doing your homework online. It was supposed to be you go home, do the homework out of the book, even out of the ebook, but it wasn't supposed to be graded online. I was supposed to pick the problem. So that was just because, just in case the class stayed remote, we had a way of doing it. So hopefully as we get back in here, it'll be more like, go do these problems, then I want to see your work when you come to class, that type of thing. Okay, let's see. Who wants to do E? Where is it negative? Go ahead. Have I already called you? I didn't call you? I skipped you? I'm sorry. What's your name?
Greg.
Greg. Okay, sorry, Greg. Greg, go ahead. Where's this function negative?
-6 and -5.
Okay, between here and here, right? Between -6 and -5, it's negative, it's below. So how would you write that?
Parentheses,
Uh-huh.
-6, comma, -5 bracket.
and not including the -6 because you have a hole at the end. Yeah, that's good. And then at -5, a bracket because at -5, you're actually down here and that is a negative value. Okay, keep going.
Do you put the U's last, or
You can do a U now. That's right. You want a union now? Okay. With what?
so bracket -4,
-4.
comma, -2,
Okay, so bracket -4, comma -2, parenthesis. So between -4 and -2, your graph is below the x-axis. At -4, it's defined. At -2, it's 0, so that's why we leave it as a parenthesis. Make sense, everyone?
Yeah.
You sure? Okay. Are you done?
oh no.
Okay, there's more. Union again. Now where else?
Do parentheses,
Uh-huh.
0,
Parenthesis 0,
comma, 2, parentheses.
2, parenthesis. Okay, between 0 and 2, your graph is below the x-axis. At 0, you can't put a bracket because there's no point here, so you can't tell me what the output is. But to the right of 0, all the way till you get to 2, it stays negative, but at 2, it's 0, so you can't put 2, right? You done?
Yeah.
Okay, good. Greg, that's great. All right, who wants to volunteer for the next one? Any questions on that one? Who wants F?
I can do it.
Go ahead. Wait, I don't know who said that.
Josiah 2.
Josiah 2, 2.0.
Yeah. I'm pretty sure.
Is that like the better version, or is that, sometimes the 2.0 is worse than the original, right? Yeah, we'll find out. We'll see, right? Okay, all right, so.
I'm pretty sure it would just be parentheses -1, bracket 1.
So we're saying parentheses -1. So what are you thinking here?
Because we're looking for where x, wow, I did this wrong. Okay.
Okay, so what you did is where is x?
Because what I looked at was the bracket on, or not the bracket, the open circle on -1 and the closed circle on 1 on the y-axis.
Uh-huh.
And then just put that, not what it's asking.
It's asking, so I'm glad we're having some time to talk about this. Does anyone have another way of saying what this is asking for? The x-intercepts of the function. You don't remember ever hearing that before? The x-intercepts of a function? The x-intercepts of a function are anywhere where the function hits the x-axis. Okay? So I want you to make sure you make a little note of that. These are the x-intercepts. I'm just going to put x-int to represent the x-intercepts. Now, Josiah, does that help narrow down kind of what we're looking for now?
Yeah, so it would be -2.
Okay. And then +2. That looks like the only two places we hit the x-axis, right? And Josiah, that's not an interval, right? Those are actually 2 points. So what do I do to represent points?
You would do the braces.
The braces. Okay, so I'm going to do a brace, -2, 2, brace. At -2 and 2, the function is 0. Okay, domain. Domain is a weird one. They didn't give me a ruler in here. Normally there's a ruler. Is there a ruler on that board? You don't see one there, do you? Oh, no, they have a big one, like a pointer type thing. So when I think domain, here's what I do, okay? I start at the far left, and I imagine having a vertical line, and I'm just going to say, when do I hit stuff? So I start here, and I start hitting stuff right after -6, right? Because there's an open hole here. So from -6, I hit stuff till I get to -5. Then I don't hit anything. Then I hit -4 all the way to 0. Now what's happening at 0? Am I still hitting something at 0? I'm hitting that dot up there, aren't I? So that means from -4, I'm hitting. Even at 0, I'm hitting. And I keep hitting until I get to 5. When I get to 5, I'm actually not hitting anything up there, but all the way up to 5, right? So, Juan, you were asking about this, so why don't you tell me what you wound up putting down?
I got -6, or parentheses, -6, and 5 bracket.
To -5, bracket,
And then union,
union,
-4 to 5.
-4 to 5, and did you have the -4 bracket or parenthesis?
Bracket.
Bracket on the -4,
And then parentheses.
parenthesis on the 5. There you go, perfect. So if you look between -6 and 5, not including -6, but including -5, you will have graph. And then from -4, starting at -4, including -4, all the way down till you get to 5, but not including 5, you will have graph. You sure? Okay, well, try and rephrase it. Are you sure?
I kind of think, why do we put the 5 if we don't include the 5? Is that what you're, like, why wouldn't we put 4, like -4, 4?
-4, 4.
If it's open at 5, then why don't we just go past it? Is that what the parentheses there for, to say it stops at 5?
Well, we're actually opening up a bigger can of worms, which is good. I'll talk about this.
Okay.
So from let's just say up to 5. Okay. If that were a solid dot, then I think everyone would agree that we would stop at 5 and this would be a bracket and we'd all be happy. How do I tell you that you can go all the way up to 5 without actually ever getting to 5? So you can be 4.9, 4.999, 4.99999, right? How do I tell you that? Well, I can't tell you go to 4.999 because there is no number right next to 5. Did we talk about that? Did I show y'all that or no? The 0.999, I didn't show y'all that? I'll show it to you right after I'm done with this, okay? There is no number right next to 5, okay? There is none. If there was, then I would tell you, go from here to here to the number right before 5. But since there is no number right next to 5, no closest number, I have to just tell you to go to 5 and not actually ever get there. And the way I do that is by putting a parenthesis. If I want you to actually get to 5, I'll put a bracket. So if I would have said -4 to 4, that would have stopped you here, but there's still a bunch of stuff here that's positive, right? So if I say 4.5 is still not enough, 4.9 is not enough, 4.999 is not enough. Make sense? So how about say 4.99999 forever? Why not do that? Why not, instead of doing this, do 4.999, how do we do that? With a bar forever? And then put a bracket. Would that mean the number right next to 5? Is 4.999 forever the number right next to 5? No? You're saying no? Why? You seem very, you don't think it is? Anybody think that's the number right next to 5? I already kind of told you there's no number right next to 5, so. But I think that would be a pretty good candidate. Okay, don't write this down. That's not right, okay? I'll explain it in a minute. Does that at all address your question, or?
Yeah, I was going to ask, why are we putting a parenthesis on negative? Because we're getting something, but it's already defined.
Same reason, is that we're saying where does graph exist, right? So there's graph here, there's graph here, there's graph here, there's graph here. The open circle means that there's graph all the way up to that point, but you never can actually get to -6. If you try -6, plug it in, you get nothing. You get undefined. It's not, there's an open hole there. So this is our way of saying everything up to -6 without actually getting to it. All right, what about range? Oh, yes, No, this is why we're here.
Because there are like 3 different parts of the function, right? And for the domain, there's only 2 parts. So did we just keep going because there are 2 points on the 0?
There's 1 point on the 0, because this one's open and that one's closed. But let me just, imagine that we had a little,
Sorry.
no, go ahead.
Why didn't we do -4 to 0 with a bracket and then do another one? Like
From where, okay, so
from
would,
0 to 5.
you could have, okay? You could have. So what's being asked is instead of doing, where is it, this one?
Yeah.
Instead of doing this in 2, could you have done this one? Let me fix it. Could you have said go from -4 to 0, including it, right?
Mm-hmm.
And then union that with 0 to 5. That would still be correct. However, you're missing the fact that this is the same, because this says go from -4, include -4, go all the way up to 0, include 0, and then start at 0, include 0, and then go to 5. You didn't have to tell me to include 0, because if this implies that 0's in there. Do you see that? So it's not wrong. This isn't wrong.
Set up a bracket for the second 0 of parentheses.
You could do that, and that would still work,
Oh, okay.
right? Because this means everything between -4 all the way to 5. Now, if you put parentheses here, now that would be wrong, because now you've excluded 0, but you actually had it. So, I mean, if your brain does better thinking that, it's fine because it's not wrong.
I was just wondering.
No, good question. Let's think about range. So domain was everything, we just start here and move across, right? Range is the same idea, but this way, starting from the bottom and moving up. So if I start down here and start looking left and right, when do I start hitting things? At this y value of -2. That's where I hit. And do I actually have a point there? Yes, solid dot. Okay? So from -2, okay, am I still hitting? Yes, over there I'm hitting. You know what? I can actually have fun with this. What? Why is it doing that? There, that was really strange. Okay, I'm gonna have to, oh no, I just messed up. Crapola. Y'all see what I did? I moved the graph, and now I'm going to have trouble getting back to where it was. Where was it?
Right there.
Right there? Okay, okay. All right, so I was trying to use this little thing to move the line up and down, but I can't get this window out of the way without moving the graph. So I have no choice. But you know what? Yeah. Okay, so we're asking ourselves, are we hitting, right? You said -2, we're hitting. What about when we get to -1? Are we still hitting graph?
Yes.
Yes, right there. And then we keep moving up, we're hitting. And then what about here? At 1, we're still hitting. And then if we go past 1, we're hitting over there. And we go all the way up till we get to 2, right? And that's where we stop hitting, finally at 2. So the range should be everything from -2 on the bottom, including -2, all the way to the highest y value we get, which is 2. Do we ever achieve 2?
No.
We never achieve it. So it's a parenthesis. Yes?
So like Bobby said, can we do like 3 different?
You could do 3 different ones, yes. Yeah, it wouldn't be wrong. It wouldn't be wrong. Okay. I think that's good. All right, so I hope that that helped in some way kind of clarify how we can look at the graph of a function and grab values off of it, determine where it's positive, negative, things like that. Do y'all want me to talk real quick about the number right next to 5 and address that? It's kind of a important concept in math. So let's just make this easier by talking about just the numbers between 0 and 1. Okay? So the question, I think, is a natural question is, what is the number right next to 1? Right? What's that number that would be right next to 1? So maybe you think it's 0.9999 forever, right? That seems like a legitimate candidate for it, right? So I'm going to show you it's not, okay? I'm going to show you that 0.9999 forever is not the number right next to 1. Okay, so ready for me to show it to you? So here's what I'm doing. I'm just going to write some things on the board. You just tell me whether or not you agree or disagree. I'm going to let x be 0.999 forever. Okay? So I'm just saying that's what it is. All right. Now what I'm going to do is just some algebra. I'm going to multiply both sides of that equation by 10. So what happens to a decimal when you multiply a number with a decimal in it by 10, what happens to the decimal? It moves which way? Which way? If I multiply this by 10, the decimal should move to the right, and it should become 9.9999 forever, right? So do you all agree that 10x, multiply that side by 10, multiply that side by 10, should be 9.9999 forever, yes? The bar means the 9s go forever. Okay, now I'd like to ask you, algebraically, so just keep that on the back burner, algebraically, if I were to ask you right now to take 10 x's and subtract an x from them, how many x's would you have? You have 9 x's, wouldn't you? Okay, but we just said that if x was, what, 0.9999 forever, 10x would be this, right? So if I rewrite this using this instead, I get 9.999 forever minus, what, x, which is 0.999 forever. What would that equal? This should be 9, right? Because all the 0.999s should kill each other off all the way down, right? And the only thing you'd be left with is 9. You agree? So this and this should be the same, right? Those should be equal to one another, which means 9x must be 9, which means x has to be what? 1. So this, if you divide both sides by 9, you get x is 1. So I started off by saying let x be 0.9999 forever, and our conclusion is that x must be 1, which means that 0.999 forever is not the number right next to 1, it is the number 1. Okay, that should be troubling, but it's true. The number right next to 1 does not exist. There is no number right next to 1. And this is a pretty profound thing, because what it means is that here's a way I could maybe convince you that there is no number right next to 1. This is just to all this is to prove to you that 0.999 forever is not the number that is right next to 1. Okay, it is 1. So let's say you found the number. Let's say that you said, hey, look, I think that this number right here, whatever it is, I think that that's the number right next to 1. Let's say that's what you believed. I can find one even closer. You know how I'm going to do it? I'm going to take the number you gave me, and then I'm going to take the number 1, I'm going to add them together, and then divide by 2. In other words, I'm going to take the average of the two numbers. So if you're ever given two numbers on a number line, this is going to come up in calculus. Okay? If you're ever given two numbers on a number line, how do you find the number right in the middle of them? That one might be easy. What's the number right in the middle of those? 9, right? 9's the number right in the middle of those two numbers. You can just kind of visually see that. But the way to actually find that is to add the two numbers and divide by 2.